exponential decay. Exponential decay is very similar to exponential growth, except that the amount is decreasing or decaying each year instead of increasing. A function of the form f of x equals a times b to the x power, with our b being between 0 and 1 and our a not equal to 0, is an exponential decay function, and it decreases as x increases. Okay, so when we're looking at our function, our a of t value is going to be our total, or our total amount, our final amount, however you're looking at it. The lowercase a is going to be my initial amount. You're going to start with a certain amount of money or a certain population or whatever. And then we have the 1 minus r. My r is going to be the rate of depreciation. Or the rate of decrease. And finally, the t is going to be our time, usually in years. Okay, so for an example here, a city population which was initially 15,500 has been dropping at a rate of 3% each year. What will the population be after 22 years? So again, we're always going to start with our formula. A of t equals a 1 minus r to the t power. Put in what I know. A of t equals my initial, we started with a population of 5,500, times 1 minus my rate, which is 3%, 0.03, to the t power. All right, and then I put in, simplify, 22, because I'm going 22 years later. So 15,500 times 1 minus 0.03 is 0.97 to the 22nd power. And then that's what I can type into my calculator, and I get a of 22 is approximately, since you can't have part of a person, we're going to round it to 7,931 people. Final answer. And this last example, again, a motor scooter purchased for $1,000 is depreciating at an annual rate of 15%. What will the motor scooter be worth in 15 years? So a of t equals a times 1 minus r to the t power. Fill in what I know. A of t equals, my initial starting was the $1,000, times 1 minus the rate of depreciation, which is 15%, 0.15, to the t power. And then if I simplify, I have a of t equals 1,000 times 0.85 to the t power. And then the last step is to actually plug in what I know. So a of 15 years is 1,000 times 0.85 to the 15th power. And then you solve that, type it into your calculator, and a of 15 is approximately equal to $87.35. So it's not worth very much after 15 years. Final answer. Those are your notes over exponential decay. Make sure you go through some practice problems and look at the similarities and differences from exponential decay and exponential growth, and then you'll be ready for your quiz over exponential functions.